Today in this video, we're going to be looking at integrating, and we're going to be using a technique called integration by tables. So that you can follow along and know what I'm talking about, you're going to have to get out your textbook, go to the back, towards the back in the index B, and it's going to be starting on page A20. Please pause it and go there, or you're going to be really confused with what I'm doing the entire time. Okay, on the top of page A20, it says integration tables. And I want you to just kind of turn the pages and look. There's several pages. In fact, there's 5 pages of these in this particular textbook. And this actually is not the end of the list. There's more integration tables out there. Just the author has stopped at this point. And we're going to come back to using this in just a minute, but I wanted to make sure you were there before we got too far into this lesson. All right, so let's just take a look at some integrations. Let's take a look at this one right here. I want to integrate x, natural log of x dx. And if I ask you, well, how would you do that? You'd have to probably think about it for a few minutes, but we've done something like that. I'm going to just rearrange things a little bit here. What if I took that x and put it in the denominator instead? Would it be any different than how I approached that one? What if I did this? What if I put them both in the denominator? Or what if I put the natural log in the denominator and had the x on top? Any of these, what seem to be very slight variations, actually change things a lot. This one here, you've got a algebraic part, you've got a transcendental part. That means you're going to have to use integration by parts. But then you could do it. This one here, well, in that one, actually I can use the power rule. The power rule, as long as you recognize that your u prime, so this is going to be my u. U prime is 1 over x, which we have a 1 over x. Okay, so I've got, that's my du. 1 over x dx is my du. And then this would be u. So then when I integrate, I get u squared over a 2, which is the natural log squared of x over 2. And if you wanted, you could put that in parentheses and have it squared. It's actually the same thing. This one, well, that one there, what we're going to end up using is the log rule. Okay, so in this case, the u is going to be the natural log of x. And the u prime is 1 over x, so 1 over x dx. Well, we have our 1 over x, we have our dx. So it'd be the natural log of, and I forgot my absolute values here, the natural log of the absolute value of the natural log of x plus our constant of integration. And this one here, well, we haven't covered that yet. That's referred to as not being an elementary function. These are all considered what are called elementary functions, basically Calc 1, an introductory level. Well, integration by parts wasn't quite Calc 1, but in other words, this is a more advanced. When you see not elementary in math, it means that's a really much more advanced problem. And we have not actually tackled one like that. My point of showing you this, though, is the idea that we've got all these variations, and they all have their own rules on how you should go about doing that. And when you start to, if you haven't noticed, the rule sheet for integration is starting to get pretty long. And statement here by the author that you cannot possibly be prepared for everything, because the formulas are endless. People keep making up new formulas that possibly need to have integrations. So what we start to do is we integrate by tables, that thing you're looking at in your book there. The idea is that once you have the equation you need, so you identify which type of integration you're doing, you identify the parts, and you just substitute in. It's kind of a little bit of it's just more like kind of finding a puzzle and then plugging the parts in, following a recipe. I like probably my best description. You're just following recipes. So I'll take this one here. I will give you the advice that if you can simplify before you start, you'll have an easier time picking out the correct integration rule. So I'm going to take the 2/3 and I'm going to put it out in front. Okay, so then I can sort of ignore that for now. What I'm looking at then is integrating where I have 1 over something squared and then twice whatever that something is, minus 5 quantity squared. Now, you got to think real generic here. Okay, so what you're looking for, you got your variable part squared. You're going to have twice the variable or some coefficient of the variable. That's probably a better way to think of it. Just in general, there's a coefficient on the variable, and then there's some sort of constant, but this expression is being squared. I would like you to start to get yourself a little more used to the tables. Take a minute here and look at, the author has broken our tables down into categories. The first category is u to the n, so there's an algebraic expression to the nth power. The second category is when there is a constant plus a coefficient of a variable, which actually kind of sounds like the one we're looking at. I would maybe be looking in that area for something like this. As you go through, there's all these different classifications. He's kind of broken them into classes. So then you've got, on the second page, you're going to see stuff that involves some square roots. That continues into the third page, where you've got things that are being squared or not being squared underneath the radicals. On the fourth page, you start your trigonometric stuff. On the fifth page, you're going to get into some of the ones with e or natural log, and some of those hyperbolic trigonometric functions, how we integrate those. Kind of get yourself familiar with the layout of your tables so that you know, like for this one here. Well, I'm not going to look on page 5 because that has to do with e and natural log and hyperbolic trigonometric stuff. I'm going to go back to towards the beginning where there was stuff that had constants and variables with coefficients. And I'd like you to pause this and try to go through and see if you can find one that fits. Ignore the 2/3 for now. Just see if you can find one that fits. Hopefully you came up with 13. 13 seems to be a very good fit. You're going to have a variable thing squared. U is always the variable part. A is a constant part. And then you've got a constant plus a variable that has a coefficient. This is just think of this as a coefficient. But that expression is squared. It almost fits this. You do have to understand you can flip-flop these. -5 then would be your constant. 2 is going to be the b, and of course u is going to be x. So you go through and basically you kind of fill out your recipe. You do need to check for the du. Du is going to be, obviously, again, du is always u prime dx. Okay, well, if u is x, u prime is going to be 1. Hey, we've got a 1. And we've got a dx. Okay, so you've got your u prime. If you don't have the parts to get your du, you might have to tweak it and balance it. And I'll do one of those in a second here. Here's the rule. At this point, you just start plugging stuff in. So that's my A, it's going to go there. It's going to go everywhere where there's an A. I'm not going to draw all of them here. But everywhere that there's an A, you plug that in. Everywhere there's a B, everywhere there's a U, and the du is sort of taken care of. So it looks like this. And at which point you can do a little bit of simplifying. I did simplify this to a point. I factored out a 25 is what I actually did. So I simplified to a point. The simplification is usually not the difficult part, and none of it's crazy difficult. You'll need to look for one that sort of matches. Maybe you have to tweak it a little bit like I did here by flip-flopping. But once you get one that matches, check to see if you've got everything for your du. It's got to be u prime dx. Tweak and balance if you need to, and then just fill in the recipe. After that, you might have to simplify a little bit, but you're pretty much going to be done. Let's take a look at this one. Okay, so obviously there's a trigonometric thing here, so you're not going to be on the first page, you're not going to be on the second page. Well, I can maybe get ahead of myself. You might, but because there are some ones where the rule has you equal to a trigonometric thing, but we're integrating a trigonometric thing, so probably not on the second page. Why don't you pause it and go try and find what rule you think would work. And here I would say this is probably going to be your u. 5x will be u. All right, I hope you found number 71 is probably a good fit. Okay, again, 5x is going to be your u. We will have to mess around a little bit. du, okay, so is going to be u prime dx. U prime is going to be a 5. Well, we don't have a 5. We have a 1 up top there. So what we'll do is we'll multiply this by a 5 to tweak it, and then we'll balance that out by putting a 1/5 out in front here. But yeah, this rule should work pretty well. So then we can go ahead and just plug in our u here and here and here. Again, there'll be a 1/5 there, but here, let me show you. So here's that 1/5. That fits my rule very nicely. And you could have the 5 there, you can have the 5 there. It doesn't really matter. And then you just plug it into the recipe. I can simplify a little bit right there, but really there's not much to simplify with this one. Don't get too hung up on the simplifying. It's just find the recipe, fill it in. And that's done. Here's another one. So you've got a variable, a u if you want up there. You've got a square root with an a and a u. And I'll give you a hint. That might be a squared, because it could be 3 squared. That's kind of a little thing to watch for. If you see a perfect square, you might go, wait a minute, could that be like an a squared? See if you can find that one. Well, in this case, I sort of led you astray. No, it didn't need to use an a squared one. This one works pretty good, number 21. Okay, so you're going to go through, and here's the rule right here. U is just going to be 1, and so our u prime dx is not a problem to get the du. Nothing. I don't have to tweak and balance this one at all. U is going to be x, a is going to be 9. Pretty much just fill it in. Pretty straightforward. Maybe simplify just a little bit when you're done. So I plug in my a, I plug in my u, plug in my b. In this case, b was just a 1. Okay, the coefficient of there is a 1. So b is a 1. And then, of course, we can evaluate. So plug in a 7 for the x's. Get what you get when you get out of that, minus what you get when you plug in zeros. And you should end up with 20/3. Now, for those of you that are quick on your feet in math, you might have jumped and said, wait a minute, couldn't we just have done that on a calculator? And yes, that is true, but I am practicing today with the tables. So, but I always want to point out that yes, anytime you're integrating from a beginning to an ending spot, you can do that. Sometimes you're going to have to deal with combinations of formulas. You start with one and then go to another one to finish it. And so I'm going to sit here, I'm going to try and integrate. I've got x to the third cosine x dx. Okay, so here's my rules. U and u. Okay, so the u, hopefully we can agree the u here is going to be x. So this would have to be u cubed. Well, these aren't to a power, these are just to the first. But down here I've got to a power. I have u to a power cosine u. This one actually seems to be a pretty good fit. And then I'm just going to plug in my stuff here. But then I actually have to do another integration. Within the rule, there's another integration. And this is going to be a u squared, which means I still can't go to one of these. I'm going to have to use this one. And notice in this rule, there's another integration. Okay, so this is not a short problem. I'm going to go through, like I said, I'm going to start with number 55. So x is the u. This is going to be u cubed. Du is going to be u prime dx, which is just 1 dx, which not an issue. That's taken care of. Okay, we've got that. So I didn't have to do any tweaking or balancing. But then I'm going to have to integrate again. But to do this part that I colored in blue this time, I have to use this rule, number 54, because I still have a x squared. I have a u to the n, so it's a variable to some power. These are to the firsts. I can't jump to those yet. But do notice this, it got notched down from a third to a second because we were subtracting 1 from the power. And that's going to happen again now. When I use this rule, I'm going to integrate again, but because I'll be subtracting 1 from the exponent, the next time it'll be to the first, which I can use then this one, and then I won't have to do any more integrations. So sometimes it's kind of nice to kind of make a plan, kind of a roadmap. Where's this thing taking me here? All right, so there's from the first one. Here's starting the second one. Now for the third one again, here at this point now I can just use this rule because this x is to the first power, which the variable there is to the first power. So then I'll just use this. My u is still just going to be an x. So I'm just plugging x's here, here, and here. And I end up with kind of a big long string here that I am going to have to simplify, but at least I'm done doing the integrations. So now I can simplify. I can distribute my 2 to these 3 places, which when I go 2 times a constant, it's still a constant, so I'm not even going to change that. But I'll also distribute my 3, and I don't know that I can do much more than that. So I distributed my 3 here, and then the 3 and the 2 together give me a negative, because this was negative, a negative 6. That's going to get distributed to this term and to this term. And the constant, didn't show what I did with the 2's or 3's because a constant times a constant is still just a constant. I don't have to do anything with it. That's that one. So integration with tables. They're pretty handy sometimes. You just go look for the one that matches. You figure out your U, your A sometimes, things like that. Make sure you're always checking for those. Make sure you have your U prime. If not, you might have to tweak and balance. Other than that, tables really aren't that bad to work with. It's just a matter of maybe getting used to where they are and where you should be looking, familiarizing yourself a little bit with the tables. So if you're in my class, there's some problems for you to practice. Have a good day.